So I'm going to be explaining the retirement problem. We're going to be depositing $6,000 in the retirement account that pays 7% in annual interest, and we need to deposit it each January 1st for the next 32 years. So first off, we're going to start off with having the year. We're going to go by the years, and we are going to find our common difference. So at the year one, we would deposit $6,000. Then from year two, we get $6,420. Now, what we realize is our ratio is 1.07, so we're going to multiply everything by 1.07, and that's how the numbers are gradually going to get higher until the year 32. So we're going to start off with our equation. We're going to be using Sn equals AI 1 minus r n squared over 1 minus r, and we're going to input our numbers into it. So Sn equals 6,000, 1 minus 1.07 to the 32nd power, and then 1 minus 1.07. Once after we do that, you're going to plug that into your calculator. You want to make sure that you do the 1.07 squared to the 32nd power. That way you don't mix yourself up. And once you do that, you're going to have negative 7.715 all over negative 0.07. So once you do that, you're going to divide that up, and then you should get 6,000 over 110.21, and after you do that, you're going to get 661,308.93. You're going to subtract that by $192,000. Now the $192,000 is the interest earned after a 3-year period, and the $192,000 is the amount that the person actually put in without gaining any interest. So once you do that, you're going to have 469,308.93, and that's going to be your compound interest. Then for the second step, we will need to figure out how much was added to the retirement account in just the last year, from between like the 31st and the 32nd year. So what we're going to do is we're going to have the equation S equals 31 equals 6,000, and then you're going to put the numbers into the equation, and with that you're going to get 612,438.25. Once you do that, you're going to subtract that from your 661,308.92, and that's going to be from all of the years together. And once you get that, you're going to have 48,870.68 in your interest. So once you do that, you're going to go to your next section, which is 8C. Write a recursive rule for how much gets added to your bank account every year. And the rule is your account grows most when you're in the last year because of the compound interest on the largest amount. So it wasn't the largest when it was in the first couple of years because you didn't have enough money and interest for it to grow higher to have that. Now that it has a lot of money to grow interest off of, that's why it's became the largest amount of growth. And then we have, actually that was 8D, sorry. 8C is write a recursive rule for how much gets added. So what we're going to do is AN equals AN minus 1 times 1.07 plus 6,000. And that equals how much was added. So the AN term, basically it's the AN term list numbers in the amount of years. And the AN minus 1 equals the previous year's amount. When doing this problem, there's also a shortcut that you can use on your calculator, and that would be pertaining to this problem. That would be the 6,000 you hit the enter, the second button, and then you get your answer, and you multiply that times 1.07, and you then add that to 6,000, and then you would hit enter, and that would also give you your answer as well. Usually when doing summation notation, you're going to have a sigma, which basically looks like a big E, and then you're going to have a number on top, which is the last term, and then you're going to have the bottom number, which is going to be your first term. So basically, like in this problem here, you're going to have your first term would be, in this problem it would be 10 over sigma I equals 3, and it would be 2I squared. So basically what you would do is you have to go up to 10. So you're going to start off with 2, and then that I is going to equal 3. So 2I squared, 2 minus 3 squared. And then you're just going to keep going until you get up to 10. Once you get up to 10, you're going to solve those simple each equations. And then you're going to simplify them, And once you do that, you will add them all up together. And if there's negatives, you will subtract and add. And then at the end of this problem, you should get negative 364. In this geometric sequence, you have A equals A1, parentheses R to the n power minus 1. So first you're going to multiply by the value each time. That's what usually happens in a geometric sequence. In this equation we're going to try to find the 30th term, and the leading up terms are 3, 12, and 48. So we're going to go based off of our equation, off of the geometric sequence, which is A equals A1, and then you're going to plug the numbers in. So A represents the last term, AI represents the first term, the R represents the common ratio, and the N represents the number of terms. So once you plug all that in this problem, you're going to always do it times the power of 10, and then you get 17. So after you multiply that all out, you're going to get 865. This is just a big number, Mrs. Sue. You know I can't understand this. It's a huge number, and that's your answer. Also, you can tell that this is a geometric series because there's no plus signs in the middle, and it's a sequence, as well as multiplying. Here we have the arithmetic sequence. The equation for that is AN equals AI plus N minus 1 times D. The D is the common difference, the N is the number of terms, the AI is the first term, and AN is the last term. After we plug in all the numbers, we're going to have the sequence of 4, 8, 12, 16, 20, and 24. And after we plug those numbers into the equation, we're going to realize that 24 equals 24, and that's correct. And you know it's a sequence because you're adding by 4 every time, but it's not like numbers being added together, like plus each other. Next, we'll be showing the arithmetic series, which is the addition of terms, and it'll be 4 plus 8 plus 12 plus 16 plus 20 plus 24. Also, in this, you will be adding the same numbers for the series. This is a geometric series, and the equation for that is Sn equals AI 1 minus Rn squared n over 1 minus R. The Sn equals sum of numbers, the AI equals the first term, and the R equals the common ratio. In this problem, we'll plug everything in, and when we get done plugging everything in, you will have 252. Also, in a geometric series, it is an infinite series where there is a constant ratio between the terms of the sequence. So this is the pyramid problem, and we know that the U.S. has approximately 300 million people at the top of the pyramid, and each person has to recruit 3 other people. What we're trying to find out is how many rounds of recruitment will it take for the entire population of the U.S. to be recruited. So first of all, we're going to realize that this is going to be a geometric series. We're going to use that equation for our problem, which is Sn equals AI 1 minus r to the n power over 1 minus r. Then we realize that the sum is 300 million, and we will start applying the numbers to the equation. So like I said before, we already know what the sum is, but the part that we need to figure out is the rate. So first we're going to involve we're going to use like the geometric series, and after you do that, you're going to get your answer, and that should be 17.4, which you could just round up to 17 rounds.